for that. I just want to say something about the initial data problem.
Yeah.
And I would like to agree with you because I like the thought of having another argument to kill fatalism, to kill presentism, with presentism being one of these philosophical zombies which needs to be killed many times.
Yes.
But I disagree with you. I don't think there's any problem at all with having initial data in a normal Newtonian way in a model in which you have radical causality. The problem is only if you think that you can have access to all the initial data at the time when you're deciding how to set some future measurement. As long as some of the initial data is epistemically off limits to you, it can all be there in reality. Just as we take, we think the initial data in the future, say a year from now, ahead of a lot of our measurement choices, all of that's there in reality. It's just epistemically inaccessible to us while we make these immediate choices. And that can be true in a vector causal model. That can be true of the present data too. It's there in reality. It plays its normal role in a deterministic Newtonian picture in determining, in that sense, both the future and the past. It's just that when we put free choice into the picture, we have to recognize that it comes with a knowledge constraint. Anything that we want to regard as causally downstream of our choice has to be epistemically inaccessible at the time we make the choice.
Well, I think I may have overstated my case when I said that this problem is characteristic of all retrocausal models. It probably isn't. But for instance, in Wheeler-Feynman electrodynamics, this problem arises on a level where there's no issue of epistemic states, there's no issue of what we can know, of what we can control, there's just the equations, and then there's the question just purely from a mathematical point of view, what kind of boundary conditions do I need to specify to determine one unique solution?
Oh yes, no, I agree, but that's a different case. I'm not disagreeing with that.
And I guess that's something that could easily happen in theories that admit for advanced interaction or other sorts of retrocausation. So it doesn't need to happen. It may be possible that already the initial data at one moment in time just picks out one consistent solution of the equations of motion, but that is something that wouldn't be surprising that it happens in theory with advanced interactions.
Ellie?
There's a point I'd like to understand with the help of weak measurement. Let's assume we have two entire particles and we perform a weak measurement right after we prepare them, and much later we perform a strong measurement in both. Would you say, according to this model, that the weak measurement would not be affected by both strong measurements?
You mean this time model? I would say that this time model is too primitive to answer this question in any meaningful way. It's really just the relevance of this model is really only restricted to this point I wanted to make, and to seeing how this advanced interaction can lead to non-local correlations, and in what sense that violates Bell's inequality. It's not a serious proposal it's not even a serious quantum theory. It doesn't agree with all the it's not empirically adequate in every way, so I would just say that it's too primitive to answer the question.
Okay, although there are further questions, the Trinity staff can't wait too long for the coffee, so we need to go to the coffee break now. So thanks to everyone for asking questions.